Preparing for a cloud support engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. A customer says their cloud-hosted website is down. How would you troubleshoot it? I would first confirm the scope. Is it down for everyone or specific users? Then I would check DNS resolution, CDN, or load balancer health, backend instance status, security groups, network ACLs, and application logs. I would also review recent deployments or configuration changes, because outages often follow changes. While investigating, I would keep the customer updated with findings, impact, and next steps. The goal is fast isolation, safe rollback if needed, and clear communication. While answering, focus on structured triage, user impact, DNS, load balancer, compute health, security groups, application logs, recent changes, monitoring alerts, and clear customer communication. Question 2. What is the difference between public, private, and hybrid cloud? Public cloud means infrastructure is owned by a provider and shared across customers through isolated accounts or tenants. Private cloud is dedicated to one organization, usually for control, compliance, or legacy integration. Hybrid cloud combines both, such as keeping sensitive databases on-premises while running web applications in public cloud. I usually explain the choice through trade-offs. Public cloud gives speed and elasticity, private gives control, and hybrid helps during migration or strict regulatory requirements. Make sure to cover ownership, access model, scalability, compliance needs, cost considerations, operational responsibility, and examples of workloads suitable for each cloud model. Question 3. How do security groups and network ACLs differ in a cloud VPC? Security groups act like virtual firewalls attached to instances or interfaces, and they are stateful. If inbound traffic is allowed, the return traffic is automatically allowed. Network ACLs work at the subnet level and are stateless, so both inbound and outbound rules must be configured. NACLs can also allow or deny traffic explicitly. In troubleshooting, I'd check both layers because an open security group will not help if the subnet NACL blocks the traffic. In your answer, compare stateful versus stateless filtering, instance level versus subnet level scope, allow and deny rules, evaluation behavior, and common troubleshooting mistakes. Question 4. A Linux VM in the cloud is unreachable over SSH. What checks would you perform? I would start with the basics. Confirm the VM is running, has the expected public or private IP, and sits in a subnet with the right route table. Next, I would verify security group and NACL rules allow SSH from my source IP. If networking looks fine, I would check the key pair, username, OS firewall, and whether the instance is overloaded. For deeper issues, I would use serial console, system logs, or detach the disk for recovery. Be sure to mention instance state, public IP, route table, security group port 22, NACLS, key pair, OS firewall, CPU exhaustion, disk issues, and console access. Question 5. Explain the difference between object storage, block storage, and file storage. Object storage stores data as objects with metadata and is accessed through APIs, so it is great for backups, images, logs, and static assets. Block storage provides raw volumes attached to servers, which suits databases and operating systems needing low-latency disk access. File storage exposes a shared file system, useful when multiple servers need common directories. The practical rule is simple: objects for massive durable data, blocks for performance, and files for shared POSIX-style access. While answering, cover access patterns, performance characteristics, durability, mounting behavior, use cases like backups, databases, shared folders, and how each storage type scales. Question 6. How would you investigate high latency in a cloud application? High latency needs measurement first. I would break the request path into client, DNS, CDN, load balancer, application, database, and external dependencies. Metrics tell me where time is spent: CPU, memory, connection counts, database wait time, and error rates. Distributed tracing is especially useful because it shows slow service calls. I would also compare before and after recent changes. Once the bottleneck is identified, fixes could include caching, scaling, query tuning, or network optimization. Make sure to cover measuring before guessing. Client latency, DNS, CDN, load balancer metrics, server CPU, database queries, network paths, logs, tracing, and recent changes. Question 7. What is IAM, and how do you apply least privilege in cloud environments? IAM controls who can access which cloud resources and what actions they can perform. I apply least privilege by granting only the permissions needed for a job, preferably through roles instead of long-lived user keys. I avoid wildcard permissions, use MFA for sensitive access, and separate admin, developer, and service responsibilities. I also review audit logs and unused permissions regularly. A good IAM setup reduces blast radius without blocking legitimate work. In your answer, discuss identities, roles, policies, permissions, temporary credentials, MFA, audit logs, separation of duties, and avoiding broad wildcard access. Question 8. A customer reports that their database CPU is constantly above 90%. How would you respond? I would first determine whether the high CPU is normal load, a bad query, or a configuration issue. I would review database metrics, slow query logs, top queries, connection counts, locks, and recent releases. Short term, I might scale the instance, reduce connection storms, or add a read replica. Long term, I would tune indexes, optimize queries, add caching, and review workload patterns. I would avoid resizing blindly unless customer impact requires immediate stabilization. Be sure to cover workload analysis, slow queries, indexes, connection counts, locks, instance sizing, read replicas, caching, maintenance jobs, and safe short-term versus long-term actions. Question 9. What happens when you type a domain name into a browser and access a cloud-hosted service? The browser first resolves the domain through DNS, possibly receiving a CDN or load balancer address. It then establishes a TCP connection and usually a TLS session. The request may hit a CDN cache, otherwise it goes to a load balancer, which forwards it to a healthy backend instance or container. The application may call databases or APIs, then returns a response back through the same path. Each layer creates troubleshooting points, DNS, certificates, routing, health checks, and application errors. While answering, walk through DNS resolution, TLS, CDN, load balancer, routing, backend service, database calls, response path, caching, and where failures can occur. Question 10. How do load balancers improve availability and scalability? A load balancer distributes incoming traffic across multiple backend servers, which prevents one machine from becoming the bottleneck. It also runs health checks and stops sending traffic to unhealthy targets, improving availability. At layer 4, it balances TCP or UDP flows. At layer 7, it can route based on paths, hosts, or headers. It can terminate TLS and integrate with autoscaling. The trade-off is added configuration complexity, especially around sticky sessions and health check design. Make sure to mention distributing traffic, health checks, removing unhealthy targets, horizontal scaling, SSL termination, layer 4 versus layer 7 behavior, and session persistence trade-offs. Question 11. How would you handle a cloud incident where multiple customers are affected? For a multi-customer incident, I would treat coordination as seriously as technical debugging. First, I would assess severity, affected regions or services, and customer impact. Then, I would involve the right engineering or operations teams and establish an update cadence. I would share verified information only, avoid speculation, and document timestamps, actions, and evidence. Once mitigated, I would support root cause analysis and follow-up actions. Customers need honesty, urgency, and clear next steps. In your answer, focus on severity assessment, incident command, communication cadence, impact scope, escalation, mitigation, evidence gathering, post-incident review, and customer empathy. Question 12. What cloud monitoring metrics are most important for compute instances? For compute instances, I watch CPU, memory, disk utilization, disk I/O, network throughput, packet drops, and instance health checks. But infrastructure metrics alone do not prove the application is healthy. I also want process status, application response time, error rate, and logs. Good alerts combine symptoms and saturation. For example, high error rate plus high CPU is more useful than CPU alone. The best monitoring helps detect impact early and points toward the failing layer. Be sure to cover CPU, memory, disk, network, status checks, process level signals, application logs, alert thresholds, saturation, and why infrastructure metrics alone are insufficient. Question 13. What is autoscaling, and what problems can it introduce? Autoscaling automatically adjusts compute capacity based on demand, usually using metrics like CPU, request count, or queue depth. It helps handle traffic spikes and reduce costs during quiet periods. However, it can introduce problems if policies are poorly tuned. Instances may scale too slowly, flap up and down, or overload dependencies like databases. I design autoscaling with proper health checks, cooldowns, capacity limits, and stateless application behavior, so scaling improves reliability instead of hiding architectural issues. While answering, explain scaling policies, metrics, cooldowns, minimum and maximum capacity, health checks, stateless applications, warm-up time, cost impact, and scaling instability. Question 14. A cloud storage bucket is accidentally made public. What steps would you take? I would immediately remove public access using bucket policy, ACL, or public access block settings. Then I would review audit logs to see when it changed, who changed it, and whether objects were accessed. If sensitive data may have been exposed, I would follow the organization's incident and notification process. I would also rotate any exposed credentials and add preventive controls such as policy guardrails, encryption, monitoring alerts, and periodic access reviews. Make sure to cover immediate containment, access policy review, public access blocks, audit logs, identifying exposed data, credential rotation, customer notification process, and prevention controls. Question 15. How do you troubleshoot DNS resolution issues in cloud environments? I troubleshoot DNS by checking what the authoritative name servers return, not just what my laptop sees. Tools like Dig or NSLookup help compare recursive resolver answers, TTLs, CNAME chains, and record types. In cloud environments, I also check private hosted zones, VPC resolver settings, split horizon DNS, and health-based routing policies. Many DNS issues are caching or scope issues. I always verify whether the failure is public resolution, private resolution, or routing after resolution. In your answer, discuss authoritative records, TTL, propagation, recursive resolver cache, private hosted zones, split horizon DNS, CNAME chains, health-based routing, and diagnostic tools. Question 16. What is the shared responsibility model in cloud security? The shared responsibility model defines what the cloud provider secures and what the customer must secure. For IaaS, the provider handles physical data centers, hardware, and core infrastructure, while the customer manages operating systems, patches, IAM, network rules, and data. In managed services, the provider takes more responsibility, but customers still own access, configuration, and data protection. I like to say the cloud secures the platform, but customers must configure and use it securely. Be sure to mention provider responsibilities, customer responsibilities, differences across IaaS, PaaS, SaaS, patching, data protection, IAM, network configuration, and compliance implications. Question 17. How would you support a customer migrating an on-premises application to the cloud? I would start with discovery, application architecture, dependencies, data size, network needs, compliance constraints, and current pain points. Then I would choose a migration approach, such as rehost, replatform, or refactor. I would plan connectivity, identity, data transfer, testing, cutover, and rollback. Performance and cost validation are critical before production. For support, I would encourage a phased migration, starting with lower-risk workloads, because big bang migrations are harder to debug and recover. While answering, cover discovery, dependency mapping, migration strategy, networking, identity, data transfer, testing, rollback, performance validation, cost estimation, and phased execution. Question 18. What are common causes of cloud cost spikes, and how would you investigate them? Cost spikes usually come from oversized resources, forgotten instances, excessive storage snapshots, data transfer, logging volume, autoscaling events, or unexpected managed service usage. I would start with billing and cost explorer tools grouped by service, region, account, and tag. Then I would correlate the spike with deployments, traffic changes, or incidents. The fix may be right-sizing, lifecycle policies, reserved capacity, budgets, or alerts. Good tagging is essential because you cannot optimize what you cannot attribute. Make sure to cover billing reports, tags, unused resources, data transfer, oversized instances, snapshots, logs, autoscaling, managed service usage, anomaly detection, and cost allocation. Question 19. How do containers differ from virtual machines in cloud deployments? Virtual machines include a full guest operating system, while containers share the host kernel and package only the application and dependencies. That makes containers lighter, faster to start, and easier to move across environments. VMs provide stronger isolation and are often simpler for legacy workloads. In cloud deployments, containers shine with orchestration platforms, rolling updates, and microservices. The trade-off is operational complexity around images, registries, networking, security scanning, and cluster management. In your answer, compare isolation model, startup time, resource overhead, portability, orchestration, security boundaries, operational complexity, and use cases for both approaches. Question 20. How would you explain an SLA, SLO, and RTO to a customer? An SLA is the contractual availability or performance commitment made to customers, often with service credits if missed. An SLO is an internal target used to manage reliability, usually stricter than the SLA. RTO means recovery time objective, how quickly a service should be restored after failure. I also mention RPO, which is how much data loss is acceptable. These terms help align technical design with business risk, cost, and customer expectations. Be sure to distinguish contractual commitment, internal reliability target, recovery time after failure, related RPO concept, measurement windows, business impact, and realistic expectations. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.